Alrighty. Okay, today's the medium. Previously solved, I guess. The kth lexicographical string of all happy strings of length n. A happy string is a string that consists of only letters A, B, C. S of I not equal to S of I plus 1 for all values of I from 1 to S dot length minus 1. Okay, so adjacent characters are not the same. Characters are A, B, C. For example, A, B, C, A, C, B are all happy strings and strings A, A, B, A, A. There's two B's here. Adjacent are not given two integers n and k. Consider a list of all happy strings of length n sorted in lexicographical order. Consider a list. Return the kth of this list or return an empty string if there are less than k happy strings of length n. So the list here, they just give you the two values n and k. They don't actually give you a list of strings to search through or to sort through. Okay, so a one length string third one. Okay, there's only going to be three one length string. Of one length string, the fourth one, there isn't any fourth one length string. It's like A, B, C, and that's it. So it's returning empty. Three length strings, the ninth one. So it ends up being CAB. Okay. A, B, A, A, B, C. Okay, strings are up to 10, up to the 100th spot. Wonder if you can pre-compute this. Yeah. I mean, I'm thinking that you probably want to just generate the kind of list. Do you want to generate it one at a time? Well, yeah, I mean, if you generate it one at a time, it's just going to be k long, right? Generate one at a time. So you do A, so if you do n equals 3, then you do A, B, A, B, C. Feels recursive, maybe. Recursive, or you can do some sort of stack that mimics the recursion. Yeah, it feels recursive. Okay. So let's say I have a kind of complete list, and I'll try to do some sort of recursion to get it. Try to do some sort of recursion to get it. Yeah, so I think maybe I don't even need to do the complete list. I just need to have the current. I just need to have a current. So current is going to be the current list of characters within the word. And then recursion here, I'm just going to think about the base case or the end case. So recursion always has a case that doesn't recurse, and then there's the recursive case. Here the recursion takes a find kth. It takes a kind of word so far, maybe the index. The word should be a list. Index, and then it returns does it return? So recurse A calls B calls A, it hits the end, and it backtracks, and then B calls C. I guess it just returns when it hits the end, and it returns the number. I guess it maybe uses a global to tell when it hits the end. So I think it just returns a true false. Yeah, I think it just returns true when it finishes it. So this is recursive. I wonder if this is a backtracking function. Backtracking. Okay, the lexicographical string. Okay, so something like the base case or the end cases. I think I need a counter. Count if index equals k, no, index equals n, then I'm done with the word. Then count plus equals 1, if count equals k, or I guess I just return if count equals k, then answer equals maybe a copy of the current word. Might as well just convert it to a string. And then return true. Otherwise return false. Otherwise, yeah, return false. So that's at the end. And then the next step here would be the backtrack. So it should start with A, then B, then C. So it should be for, let's see, if index equals 0, then the start is going to be A, B, C. And I guess for each letter in start, or depend letter, and then find kth would be passing the word index plus 1, and then if that doesn't work, then it does something like word.pop. So it does A, then B, then C into the array. I guess here this should be an if, because it's going to return if this is false, if this is not true, or if this is true, then just return, I guess. I guess it doesn't matter here, return true. And then it does all the starting ones, and then otherwise it returns false. So that's for the starting index. Every other index has a prior index to go off of. Okay, actually maybe this should just be if index equals 0, then prior equals, say, z, and then possible, or say values, is going to be a, b, c, and then for every letter and values, if the letter is equal to the prior, actually, so I think prior should be equal to z if index equals 0, else prior should be whatever the last letter in the word is. So for every letter and values of letter not equal to prior, or if it equals prior, then just skip it. And then otherwise it does this process here. Appends the letter, moves to the next index, returns true if it finds it. Otherwise it keeps on searching, returns false after it finds nothing. Okay, and then I just need to initialize it. I need to just call it find kth, or I guess maybe current is equal, count equals 0, current equals empty list, find kth. I guess I should have an answer, huh? Answer equals empty string if find kth. Actually, I just call find kth, right? And then the answer should be initialized at some point. Missing one required argument, starting index 0. Count is a local variable. I guess I could pass count, or I could just make count a field. Self.answer, yes, I did mean that. Okay. Interesting. So not particularly fast. It's decent. I'll improve this. I guess I could make this into a for loop version rather than recursion version. It might save on some stack, some call stack stuff. Self.count plus 1 increments. Oh, yeah. It does go through every single possibility. Wonder if it can skip some stuff. Wonder if we can skip some stuff. So when n equals 3, n equals 3. Let me go ahead and try to now analyze this. ABA, ABC, ACA, ACB, BAB, BAC, BCA, BCB, CAB, CAC, CBA, CBC. Okay, so can I somehow skip doing certain maybe starters if I know that like 1/3 of the all possible things start with A, and let's say K is in like the second third or third third of the number of possible things, then I can just start with the correct letter. So if n equals 3, then obviously there's 3 startings, and then I guess this should be 2 times 2 times 2, right? So it'd be 3 times 2 times 2 is 12. Okay. So it's 2 times 2 as the number of things that start with A and B and C. I wonder, can I just mathematically determine it? Right? Can I mathematically just figure out the formula from K to the letter? Because it's 3 and then 2 and then 2. 3 for ABC, and then after A or after a certain letter, there's 2 possibilities for the next letter. So let's say arbitrarily n equals 5, and I'll say k equals 17. So that'd be 3 times 2 times 2 times 2 times 2 times 2. First letter has 3 options. Every other letter after that, which is 4 letters, there's 2 options. So it's 3 times 16. So that's 48. So 17 would be within that first third. So out of 48, 48 would be 16, then the first. Do I need to calculate this number first? So 17 out of 48, that would be, that'd be the first thing. So it'd be like BA, it'd be just the very first thing. BA, 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 something like that. BA, BA, BA. So, test case. N equals 5, number 17. Okay. How would I figure this out without doing this much math? So if I thought about it in terms of I would need to figure out which part of the 48, the first third, the second third, or the third 17 is in. So I calculate 48. I calculate that each third of 48 is 16. Then I do 17 mod 16 and get 1, so it'd be the first of the 16. I guess 17. So if this was, let's say, 20, let's go 25 then. So 25 mod 16 is 9. So it'd be 9th out of the 16. 9th out of the 16. So I think what it means is this next number is going to say that it does mod 8. The 3 here carries a value of like 16. The 2 here carries a value of 8. 48 divided by 3 is 16. 16 divided by 2 is 8. So the 9th thing is like the second set of this. Interesting. And then the next set be 4. So you start with the total number of values. Okay. Start with the total number of values. You do that number divided by the possible things at that spot. And then you do k mod that number, get a remainder. The remainder pushes to the next index. The remainder pushes to the next index. Okay. So let's do the simple case here, trivial case, not possible. So the total number of values is going to be 3 times 2 to the power of n minus 1. Assume n has to be at least 1. So it's going to be starting with, if n is 1, then it's going to be just 3. If n is 2, then it would be 6. So if k is greater than total, is that right? K is greater than, yeah, great. K is greater than total, then return not possible. If k is greater than total, count of n length strings. I guess this is kind of And then I guess I should do something like, I should just do the starting one, because the starting index is not going to be the same as the other ones. The other ones have only two possibilities. That doesn't match a previous, but this starting one could have it. So I guess I could probably do something like if n equals 1, return return the array that is A, B, or I guess how would this work? I guess it's just going to be A, B, or C. And return array at A minus 1. Okay, and then here I'm assuming that, well, here n has to be greater than 1, n has to be 2 or more. So let's say the count is equal to total divided by 3. And then k equals k mod count, I want to say. I guess this should probably just be k mod count. So if it was like 16, total is 48. 48 divided by 3 is 16. K becomes 17 mod 16, which is 1. I guess I first need to figure out which slot it's in. Slot should be total, should be K divided by count, yeah. So it should be slot 0, slot 1, or like slot is like the third, the first third, the second third, the third third. And then K becomes the remainder, 17 becomes 1. So I guess the answer is going to be an array that starts with ABC at slot. And then for every later index in range n. Every later index in range n. I could use slot as the previous. So the options for this current one is going to be if the slot previously was 0, then it's going to be BC. If the slot previously was 1, it's going to be AC. Lastly, it's going to be AB. Pretty close. So the count should lower count should be equal to the count divided by 2. Oh, so close, so close. Slot equals k divided by the current count now. That's wrong. I think I need to do something like no. No, maybe that is right. I think this should be all options is here. And then options here should be all options at the slot. So if the slot was previously 0, which is to say that it's the first third, so the second letter has to be B or C. If it's the second third, then the second option should apply. Yeah, the slot is kind of like, is it? No, I'm doing this wrong. So I have to look at my previous letter, and then based on my previous letter, the options apply. So answer, so options, so all options should be something like, if it's A, it goes to BC, if it's B, it goes to AC, if it's C, it goes to AB. So it should be like a mapping. And the options for this place is going to be all options at using the previous letter in the current answer. Yeah, okay. Okay, then the count is divided. The slot becomes k divided by count. And then something like k equals k mod count. I think. So 9 mod 4 is going to give you 1. Is that right? Nine divided by 4. 9 divided by, what's going on here? So n equals 5, k equals 25. So k is that. So mapping this will be slot. So count is equal to the 3 times 2 times 2 times 2 times 2 originally, which is 48. Count becomes equals to total divided by 3. Oh, okay, so total is equals to that. Count is equal to 48 divided by 3, which is 16. Slot becomes 48 divided by, no, 25? 25 divided by 16, which is is 1. So it's the first slot, so it gives me B as the first letter. And then K becomes equal to 25 mod 16, which is 9. Okay, so it starts with a B. And the second iteration, or the first iteration of the for loop would be, there's 16. This is 9 out of 16. It's 9 out of 16, right? So based on this, the options would become AC, because it's not B. And then 16 count becomes equal to 16 divided by 2, right? 16 divided by 2. So there's 8. So 8 starting with A, 8 starting with, or 8 with A, 8 with C. So is that the count or is that the slot? No, that's the count. The slot is 9 divided by 8, which is 1. 9 divided by 8. Yes, so this should be K divided by the count now. The count is 8. So the slot is 1. The slot is 1, which means that's C. Let's see. The slot should now make this into answer pens options at the slot. No, I guess that's the next iteration. Is that the next iteration? Slot is now K. Options count slot. No, answer should append this, yeah. Options at the slot, so it should append C. K equals K mod count, so K becomes 1. K becomes 1. Nine divided by 8, 9 mod 8. And then it iterates the next set next time. And then it should return the join of the answer. Oh, this is a dictionary, so it should not be in square bracket. It should be curly. Division by 0. It's not good. Slot is K. The count divided by 2. Oh, I see. Maybe this should be index. Yeah, it should be index in. This should be in range n-1. I'm actually not using this as an index at all. I'm just using this number of times to iterate. Oh, shucks. One off. So it's looking like it maybe does everything except the last one. B-A-B-A-C. B-A-B-A-C. I don't know why it does the last one wrong. Or it does the last one wrong on those examples. I guess these are the base case stuff. This is not handled with the general case. Three, 9. I wonder if it's because of the K. I think maybe I should just lower K minus 1. Is that the issue? Yeah, I think this might be because of K is 1 off. I'm using kind of 0 indexing for K rather than 1 indexing. Yeah. Guess I could just do if greater, all this stuff is fine, and then just say K equals K minus 1. Huh, interesting. I don't know if I did this. Kind of curious as to how I did this previously, to be honest. But whatever. Yeah, I mean, not having to do recursion to actually calculate all K values, but just going straight to the Kth one, using a kind of direct logic for it. Pretty fast. Okay, summary. So for summary here, tried 2 methods to find the kth. The first method used recursion with backtracking, I would say. This is with backtracking. Recursion, yeah, kind of backtracking to iterate over every sorted string of length n and stopped when the kth one is found. Return that string. Yeah, so for the recursion method, this was it. You have a recursion function. This is the base case here. The recursion takes in an array of kind of characters, index that's at, which technically is just the length of the array. If the length of the array matches the length of the strings that are to be formed, then you have a global counter that increments. If the global counter has reached k, then whatever is in the array now is the answer. So just kind of return that. It uses I guess it could use a return value here. Yeah, I could have just returned that value, but I just set just a global field variable to the correct answer and return true or false for the function itself. I could just return the answer or an empty string if it's not the answer, I guess. But whatever. So that's the base case. The recursive case in the recursive function would be So if the index is 0, that means that you're dealing with something that doesn't have a prior letter, so every letter could be A, B, or C. But if the recursion is at an index that is not 0, that means it's later on, so there is a previous letter that the next letter can't be. So that previous letter, yeah, it can't be the next one. So all the values between A, B, and C for every letter in there. If it's not equal to the prior, then you can try to append that to the array of characters. Call your backtrack, call your recursion, and if it works, it works. Return if true. If it doesn't work, then pop the letter and iterate through the next possible value. Then return false if it all doesn't work. And then you have your kind of call your recursive function. But the faster version, downside of this method is that it will need to basically generate every string within the kth ordering, within the k ordering, before reaching the answer. So if it's like k is 1,000, then it has to go through 1,000 letters for 1,000 different versions of the correct substrings of length n, or correct strings of length n, before it realizes that. The faster version directly calculates the kth based on kind of logic math. Can do the simplified logic using examples. So example is like n equals 5, k equals, what was it, 17. This implies that there's a total of 48 possible. 3 times 2 times 2 times 2 times 2, of which 17 is the first that starts with B. 48 divided by 3 is equal to 16, so that means that there are 16 that starts with A. And then this implies this, the first one that starts with B would be BAB, AB. And then example n equals 5, k equals 25. Again, there's total of 48. And the 25th one is the 9th that starts with B. 25 is in the second third, where the first third starts with A, the second third starts with B, the third third starts with C. So 25 mod 16 is equal to 9. And then from there, the 16, like half of them will be second letter A, or yeah, since it starts with B, second letter is going to be A or C. So 8 of the 16 starts with 8 of the 16 have a second letter of A, 8 of the 16 have a second letter of C. So like 9 mod 8 is equal to 1, and 9 divided by 8 is equal to 1. So you're dealing with kind of the first one that starts with C as the second letter. So this implies that it's going to be BC to start. And then just expand expand that logic to other indices. So, I mean, it took me a while to figure it out, but I have a total variable, this total of all possible. If k is bigger than the total, then just return empty string because it's not possible. I don't even know why I have this ABC character, but whatever. If n is equal to 1, then just do that base case, or do that kind of trivial case. For the logic here, I just made it 0 for the first kind of possible thing. And then I have basically k, count, and slot. Count is the total number of possibilities at that particular position. So if there's 48 possibilities, and at that position, at the first position, it could be A, B, or C. Then the count would be 16. 48 divided by 3, so that means that there's 16A, 16B, 16Cs. If I'm dealing with the second slot or the second index, where there's 16 count at that point. 16 divided by 2 is going to be 8, so it'd be 8 of one and 8 of the other. And slot is which part of that 0, 1 or 0, 1, 2 is the thing. And then k is kind of this remainder calculation. Answer is usually like A, B, or C. All options refers to is kind of dictionary to limit the next set of options based on the previous. So if the current option is, or the previous letter is A, then the current options is BC. B is AC, C is AB in order, right? And then for every index after the first, so it'd be n minus 1 remaining indices. The options at this index will be based on all options taking in the previous letter. And then you do count divided by 2 because every index after the first has only 2 options. So it reduces the previous count by a factor of 2. And then slot is the kth element into either the first or the second option, or the 0 or the first index. Answer appends that option, and then k becomes the modulo of k and the count. And then you just convert your array into a string. Alright, time complexity is going to be O of n. Is it? Yeah. No. It's going to be O. I want to say log base 3 of log base 2.5. So it's this log of k. Log of n or log of k? I guess it must be log of k. Yeah, it's log of k. Log of k has the iterations of the loop using the direct method will reduce k by a factor of 2 or 3, or technically 3, or 2 each time. Yeah. And then space complexities can be basically just be ov1. Ov, no, it's gonna be ov(n) to store the temporary array of characters before converting it to a string.